Hi everyone. So now what we actually want to do is instead of this wheel spinning for infinite amount of time, what we want is this wheel should spin momentarily when we click the wheel. Okay. So to do that, we actually need to create a spinning animation. Instead of an infinite spin, we want to create a short animation for, let's say, 2-3 seconds. The wheel will spin and it will stop at a certain, after rotating after a certain angle or certain degree. Okay. So for that we will study tweens. Okay, so tweens are used to create some basic animations in phaser. Okay, so you can create a lot of interesting animation. For example, if I give you one example here, so basically what happens is when you're rotating the wheel, you are actually changing some property of that sprite during the duration. For example, in this case, you can see we have created a tween that basically that fades the girl. Okay, so let me show you here what happens here. Okay, code is getting loaded. Let's try to reload it. Okay, so we have the code here. So basically this is how you create a tween. So in the tween, you have to use the tweens object to add a tween, and in the target you specify on what object this tween will be applied. So basically you're changing the property of a object during a certain duration. For example, over 6000 milliseconds, you are changing the alpha value of the girl from 1 to 0.1. Okay, so you can see there is a smooth transition from value from 1 to 0.1, and delay means it starts after 2000 milliseconds. Once this tween is triggered, it will start after a delay of 2000 milliseconds. So if I just go to this particular screen, you can see the girl gradually fades out. Okay, and it stops at an alpha value of 0.1. So we need something for the wheel. So what we need to do in wheel is, instead of changing the alpha value, we actually need to change the angle of the wheel. Okay, so let me go to this thing. So what we will do in the update function, we will first stop the movement of the wheel. We do not want a continuous movement. We just want this to be triggered when the spin wheel function is being called. So here what we will do is, we will put this code, we will add a tween here. Okay, so I can say we have created a tween, and in the targets it would be this dot wheel. Okay, we want this tween to be applied on a wheel. Alpha value, let's say 0.1, delay is 2000. That's fine, we can just remove the delay as well. And let's see what happens in our case. So once I click this, you can see the wheel gradually fades to an alpha value of 0.1. Okay, so this event got triggered when I click the mouse. But instead of doing this, what we can say is, let's say angle becomes 70. Okay, so let me click this, and you can see once the angle becomes 70 degree, it will stop. So the wheel rotates. So we need something like this. Okay, we need something like this. If I say angle is, let's say 1700. Okay, so that means on one 360 turn, it will rotate for one circle. For 720, it will rotate for 2 circles, and so on. So it will be around 5 or 6 circles it will rotate before stopping. And duration is, we can reduce the duration as well. Okay, so let me say duration is 3000. So when I click this wheel, so you can see it rotates and it stops. Okay, so what we need to do is, we need to generate this number randomly. Okay, so we have to generate this randomly so that our effect is triggered. Okay, so another thing you will observe is, what happens is, the angle starts from 0, it becomes 1, it becomes 2, it becomes 3, and it becomes up to 1700. Okay, so that is why you see the animation. It's not an abrupt change. You're not going from 0 to 1700, but it's taking all those values which come from the range 0 to 1700 over a duration of 3000 milliseconds. Okay, but what happens is, let me just draw a graph here. So let's say this is the duration, and this is let's say the speed. Okay, so the entire duration the wheel runs with the same speed. Okay, but this is generally not the case. When you rotate a wheel, initially it will accelerate, the speed will increase, and gradually, because of the momentum getting lost, it will try to slow down. Okay, so we need some slowing down of the wheel when it is about to stop. Okay, so if you carefully see, it stops abruptly. It stops from a speed of, let's say, 100, it directly becomes 0. So suddenly the brakes are applied, but in general it does not happen like that. Okay, so we can add a easing effect. So you can refer these effects from the phasor examples. So I'm going to use an effect called cubic ease out. Okay, so it's like a mathematical function. We are defining, okay, how slow or fast it should go. So if I now spin the wheel, so initially it is fast. Okay, I think there is some mistake. It should be O, capital O. Let's try to run this again. Okay, now you can see the spinning is, let me reduce it to, let's say, 800 only. So now you can see the wheel slows down. Okay, so the wheel is initially fast, but the speed gradually reduces when we have to stop. So you can use this animation. Okay, you can use this easing property with this particular value to simulate this slowing down effect. Okay, and another thing that we can add to this tween is, once this tween is complete, okay, once this period of 3000 millisecond is over, we can actually trigger a function to do something. Okay, so we have to show the results to the user. So we can say console.log, you want something. So we want this statement to be triggered, and we will see in the next video how to implement the wheel logic. Okay, how to implement the wheel logic. So we got some error here, line number 89. Okay, line number 89. Yeah, it should be a comma here. Okay, so you can see this statement automatically got printed. You want something. Okay, so you want something. So that means we are able to detect when the wheel has stopped rotating. So I hope these concepts are clear, and in the next video we will discuss the logic to implement how to detect what you have won. Okay, so that's what we are going to see in the next video.